National Electrical Code Section 605.7 addresses the requirements for electrical systems within manufactured office partitions. The specific question concerns the use of a single grounding conductor for multiple circuits within a flexible whip supplying power to these partitions. The code permits the use of a single grounding conductor for multiple circuits within a whip. This means that for your application involving 3 circuits feeding the partitions, a single grounding wire is acceptable, provided it meets the ampacity requirements outlined in the NEC. The key requirement is that all ungrounded conductors must deenergize as stated in NEC 605.7. This can be achieved with a single grounding conductor adequately sized. It's essential to understand the fundamental principles of grounding to appreciate why this is permitted. The grounding conductor's primary purpose is to provide a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers or fuses. When a fault occurs, such as a short circuit between a hot conductor and a grounded metal part of the partition, the fault current flows through the grounding conductor back to the electrical panel. This high current causes the circuit breaker to trip, interrupting the power supply and preventing a potentially dangerous electrical shock or fire hazard. The size of the grounding conductor is crucial. It must be sized appropriately based on the size of the ungrounded conductors supplying the circuits. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating or setting of the overcurrent protective device in the circuit. For example, if the circuits are protected by a 20 amp circuit breaker, the minimum size of the grounding conductor is typically 12 American wire gauge copper or 10 American wire gauge aluminum. If the circuits are protected by a 30 amp breaker, the minimum size is 10 American wire gauge copper or 8 American wire gauge aluminum, and so on. It's always best to consult the specific table in the NEC to ensure compliance. In your case, since you have 3 circuits within the whip, you need to ensure that the single grounding conductor is sized to handle the potential fault current from any of those circuits. This means you should base the grounding conductor size on the largest overcurrent protective device protecting any of the 3 circuits. If one circuit is protected by a 20 amp breaker and the other 2 are protected by 15 amp breakers, you would size the grounding conductor based on the 20 amp breaker. The NEC also addresses the types of grounding conductors that are permitted. Typically, equipment grounding conductors are copper or aluminum and can be either bare, covered, or insulated. If insulated, the insulation must be green or green with a yellow stripe. The grounding conductor must be securely connected to the metal parts of the office partitions and the grounding busbar in the electrical panel. Proper connections are essential to ensure a low impedance path for fault current. Loose or corroded connections can increase the impedance, reducing the effectiveness of the grounding system and potentially delaying the operation of the overcurrent protective device. In addition to the grounding conductor, it's also important to ensure that the metal parts of the office partitions are properly bonded together. Bonding is the process of connecting all metal parts to form a continuous electrical path. This helps to minimize voltage differences between different parts of the partition, reducing the risk of electrical shock. Bonding can be achieved by using bonding jumpers, which are short lengths of wire that connect the metal parts together. These jumpers should be sized appropriately based on the size of the equipment grounding conductor. It is also important to consider the requirements for flexible cords and cables. The flexible whip that you are using to supply power to the partitions must be listed for the purpose and must be installed in accordance with the NEC. The flexible cord or cable must contain an equipment grounding conductor, and this conductor must be connected to the metal parts of the partition and to the grounding busbar in the electrical panel. The length of the flexible cord or cable is also limited by the NEC. The maximum length depends on the ampacity of the conductors and the application. In general, shorter lengths are preferred to minimize voltage drop and to reduce the risk of damage to the cord or cable. The NEC also addresses the requirements for receptacles and other electrical equipment that are installed in office partitions. Receptacles must be of the grounding type and must be properly grounded. This means that the receptacle must have a grounding contact that is connected to the equipment grounding conductor. Other electrical equipment, such as lighting fixtures and appliances, must also be properly grounded. When installing electrical systems in office partitions, it's important to follow all applicable codes and standards. This includes the NEC as well as any local codes or regulations that may apply. It's also a good idea to consult with a qualified electrician to ensure that the installation is safe and compliant. A qualified electrician can help you to select the appropriate wiring methods, grounding conductors, and overcurrent protective devices. They can also inspect the installation to ensure that it meets all applicable requirements. In summary, according to NEC 605.7, a single grounding conductor is permitted for multiple circuits within a whip supplying power to office partitions. The grounding conductor must be sized appropriately based on the largest overcurrent protective device protecting any of the circuits. It must also be securely connected to the metal parts of the partition and to the grounding busbar in the electrical panel. Following these guidelines will help to ensure a safe and compliant electrical installation. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you are unsure about any aspect of the installation. Always deenergize circuits before working on them and use appropriate safety equipment, such as insulated gloves and safety glasses. Staying informed about the latest code requirements and best practices is essential for ensuring electrical safety. Furthermore, always verify the specific requirements of your local jurisdiction, as they may have amendments or additional regulations that supersede or supplement the NEC. It is also advisable to maintain detailed records of all electrical work performed, including wiring diagrams, conductor sizes, and overcurrent protection ratings. This documentation can be helpful for future maintenance and troubleshooting. It is also important to consider the potential for future expansion or modification of the electrical system. When installing wiring and equipment, it's a good idea to leave some extra capacity to accommodate future needs. This can save time and money in the long run by avoiding the need to replace undersized conductors or equipment. Regularly inspect the electrical system in the office partitions to identify any potential problems. Look for signs of damage to wiring, loose connections, or overheating. Any problems should be addressed promptly to prevent electrical hazards. Consider using arc fault circuit interrupters or ground fault circuit interrupters to provide additional protection against electrical fires and shocks. Arc fault circuit interrupters detect arcing faults, which are a common cause of electrical fires. Ground fault circuit interrupters detect ground faults, which can cause electrical shocks. In your specific application, it is also important to consider the type of partitions you are using. Some partitions may have specific requirements for electrical installations. Consult the manufacturer's instructions to ensure that you are following their recommendations. Also, if the partitions are located in a damp or wet location, additional precautions may be necessary to protect against electrical shock. This may include using waterproof enclosures and ground fault circuit interrupters. Remember that the NEC is a comprehensive document, and it is essential to read and understand all applicable sections before performing any electrical work. The code is updated regularly to reflect changes in technology and best practices. Staying up to date with the latest edition of the NEC is crucial for ensuring electrical safety. If you have any questions about the NEC or electrical installations, consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your installation meets all applicable requirements. Consider attending training courses or workshops to enhance your knowledge of electrical codes and practices. These courses can provide valuable insights and hands-on experience. They can also help you to stay current with the latest developments in the electrical industry. Remember that electrical safety is everyone's responsibility. By following the NEC and best practices, you can help to prevent electrical accidents and protect lives. Regularly review your electrical safety procedures and practices to identify areas for improvement. This can help you to create a safer work environment for yourself and others. Also, encourage others to report any electrical hazards or concerns. By working together, you can create a culture of safety and prevent electrical accidents. When in doubt, always err on the side of caution. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician. It is better to be safe than sorry. Keep in mind that the NEC is a minimum standard. In some cases, it may be necessary to exceed the requirements of the code to ensure adequate safety. Consider the specific hazards and risks associated with your application and take appropriate precautions. Remember that electricity is a powerful force, and it must be treated with respect. By following the NEC and best practices, you can help to ensure that electrical systems are installed and maintained safely. Also, be aware of the potential for induced voltage when working with electrical circuits. Induced voltage can occur when a conductor is located near an energized circuit. The induced voltage can be high enough to cause an electrical shock. To prevent induced voltage, always deenergize circuits before working on them. If it is not possible to deenergize the circuit, use insulated tools and equipment. When working with electrical equipment, always wear appropriate personal protective equipment, such as insulated gloves, safety glasses, and hearing protection. Personal protective equipment can help to protect you from electrical shock, burns, and other injuries. Regularly inspect your personal protective equipment to ensure that it is in good condition. Replace any damaged or worn equipment. Be aware of the potential for static electricity when working with electronic equipment. Static electricity can damage sensitive electronic components. To prevent static electricity, ground yourself before handling electronic equipment. You can ground yourself by touching a grounded metal object or by wearing a static dissipative wrist strap. When working with electrical equipment in a confined space, be aware of the potential for oxygen deficiency. Oxygen deficiency can occur when there is not enough ventilation in the confined space. To prevent oxygen deficiency, ensure that the confined space is adequately ventilated. If it is not possible to ventilate the confined space, use a self-contained breathing apparatus. Be aware of the potential for hazardous materials when working with electrical equipment. Hazardous materials, such as asbestos and lead, may be present in older electrical equipment. To prevent exposure to hazardous materials, follow appropriate safety procedures. This may include wearing personal protective equipment, such as a respirator and gloves. Dispose of hazardous materials properly.